Vector Applications, page 8. Quadrilateral ABCD is formed by these lines where R, S, T, and U are scalars. Use vector methods to find the coordinates of ABCD. This is just like the last problem in the previous page. So, for example, if we want to find point A, we would look at these two sets of equations, and we would set the x component equal between the two of them. So like the first one would be x would be 2 plus 4r, and in AD the x component would be 3 minus 3u. And then we would set the y components equal, so it would be 5 plus r is equal to 1 plus 12u. And then we're just going to solve for, like for example here, we're going to solve for r. So we get r equals negative 4 plus 12u. And then we'll put that in here. And then we get two, we're just doing two equations, two unknowns. Negative 4 plus 12u equals 3 minus 3u. 24, or 20, 2 plus, and then negative 4 times 4 is negative 16, and 4 times 12u is 48u, and then we subtract, we add 3u to both sides, we get 3, so now we have 51u equals 3 minus 2 plus 16, which is equal to 1 plus 16, 17. So u is equal to 17 divided by 51, I think is 2/3. No, it's 1/3. Right? 17 divided by 51 is 1/3. So u is 1/3. And r is equal to negative 4 plus 12 times u, so it would be negative 4 plus 4, so r is equal to 0. Okay? So that is all to find coordinate A. So coordinate A is going to be equal to, we could use r equals 0, that's probably easier. Put r equals 0 in there, and we'll just get that A is 2, 5. Okay. Now we're going to find coordinate B. So let's see, coordinate B. Coordinate B, we need to use this and this. So we're going to have 2 plus 4r is equal to 18 minus 8s. And for the y, we're going to have 5 plus r equals 9 plus 32s. And let's solve for r. So r is equal to 4 plus 32s, and then we'll put it in there, and we'll have 2 plus 4 times 4 plus 32s equals 18 minus 8s. So 2 plus 16 plus 4 times 32 is 128 s equals 18 minus 8s, so that would be 136s equals 18 minus 18 is 0, so s is equal to 0, and r is equal to 4. So, and this we're looking for, in this case, B. So we'll look for B using this equation here. And so B is equal to 18, 9. We've already found B also. Okay. Now we'll look for C. C, we're going to use this one and this one. So we're going to have 14 minus 8t is equal to 18 minus 8, minus 8s. And then the y's, we'll put 25 minus 2t and 9 plus 32s. And then let's see, we will solve for t maybe. So put 2t is equal to 25 minus 9 minus 32s, which is equal to 16 minus 32s. That's 2t. So t is equal to 8 minus 16s. So put 14 minus 8 times 8 minus 16s equals 18 minus 8s. Put that there. So 14 minus 64, and 8 times 16 is 128. 128s equals 18 minus 8s. So we add 8s to here, we got 136s equals 14 minus 64 is negative 50. Add 50 to both sides, we get 68 on this. Oops, not yet. So 18 here, and then we're going to get 68. 136s equals 68, which is equal to, so s is equal to 1/2. S is equal to 1/2, and then t is equal to 0. Right? Because if you put s equals 1/2 in there, you're just going to put t equals 0. And then now we're going to find C here. Oops, something happened. So when you put t equals 0 up here, then it gives you that coordinate C is going to be equal to 14 and 25. Okay, so on to D. Okay, so D. D, we're going to look at this one and this one. So for the x component, we put 14 minus 8t, and we set that equal to 18 minus 8s. Oh, I'm sorry. Set that equal to 3 minus 3u. So that's one of the equations. The other equation would be the y component, so it would be 25 minus 2t equals 1 plus 12u. Okay, let's solve for one of these variables, like but 2t equals 24 minus 12u. So t is equal to 12 minus 6u, and we can put that in here, and then we get 14 minus 8 times 12 minus 6u equals 3 minus 3u. So 14 minus 8 times 12, I think, is 96. Negative 8 times minus 6 would be plus 48u equals 3 minus 3u. Add 3u to both sides, and then we get 51u equals, let's see, 14 minus 96 would be 82, negative 82. And let's see, add a 3u to there. Okay, and then so we have 51u equals 3 plus 82, which would be 85. So u equals 85 divided by 51, which just looks like a mess, but actually, I think there's a common factor here. 51 is equal to 3 times 17, 85 equals 5 times 17, so that's actually equal to 5/3. So u is equal to 5/3, and then we could put 5/3 into here, and then we'll have that t is equal to 12 minus 6 times 5/3, so that would be 30 divided by 3, so 12 minus 10, so t equals 2. So now we know that t equals 2, u equals 5/3, and so let's figure out what the coordinate d is going to be. So we could put in t equals 2 in for this one here, and then so we'll have, for the x coordinate, we have 14 minus 16, so that it would be negative 2, and for the y coordinate we would have 25 minus 4, which would be 21, so d would be negative 221. And then we can take all those 4 coordinates, okay, and then we'll mark the coordinates here. We got this C, we got D, A, and B, and we're going to find out what the vectors AC and DB look like. Okay, so it's a color we haven't used for. So let's see, AC would be equal to the C vector, which is 14 and 25, minus the A vector, which was 2 and 5, so that would be equal to 12. 25 minus 5 is 20. Okay, so that's the AC vector. Then the DB vector is equal to the B vector, which is 18 and 9, minus the D vector, which is negative 2 and 21. And we'll end up with 18 minus a negative 2, which is 22. I'm sorry, 18 minus a negative 2 is just 20. And then we'll have 9 minus 21, which is negative 12. And then we can find the magnitudes of each one of those. So the magnitude of this would be the square root of 144 plus 400. So it would be the square root of 544. And this one also the square root of 544 for the magnitude. So AC, the magnitude of AC and the magnitude of DB are actually the same. Okay. Let's make this a little smaller. Okay, and that was part B1 and 2. And then we're going to now find the vector product of AC and DB. So AC scalar product DB would be 12, 20, dot product 20, negative 12. And we can see right now that that's going to be equal to 0, because 12 times 20 minus 12 times 20 is going to be 0. Okay, so that means that AC and DB are actually at 90 degrees to each other. And so if we draw a picture of our quadrilateral ABCD, we just found that AC and DB are the same length. They're both square root of 544. And we also found that those two vectors are at right angles to each other. So that tells you that that the quadrilateral ABCD is a square, right? Because it's got to be some kind of like rhombus if the diagonals are at a right angle to each other. But not only that, they are the same length. So if they're the same length, also it's not like a any rhombus. It's a special rhombus. It's a square. Okay, so that's the answer to C. Okay, moving on. Okay, 13G, relationships between lines. If lines are coplanar, they may be parallel or perpendicular or intersecting. Okay? If lines are not coplanar, they are skew. Okay, so skew is like, one line is going above here and the other line is kind of going down here, and they are separated by a distance there. Okay, imagine that in 3 dimensions. Calculate the following line pairs as either parallel, intersecting, coincident, or skew. Oh, I made a mistake here. This is not perpendicular and intersecting are kind of perpendicular is a special case of intersecting. What we want here is coincident, I think. So it's either the same line, parallel, or they intersect. Okay. So here we're going to say classify the following lines as parallel, intersecting, coincident, or skew. In each case, find the measure of the angle, acute angle between them. Okay. So what we're going to do first is we're going to figure out the direction vector. So we're going to have the position vector, which is 1, 2, 3. And then we'll have the direction vector, which is 2, -1, 1. Okay? And then we'll look at this other one. It's -2, 3, 1. And the direction vector is 3, -1, 2. Okay? So they're obviously not parallel because the direction vectors are different. Let's see. They're not coincident because the direction vectors are also not the same. So they're not parallel, they're not coincident. So that means they're either intersecting or skew. Let's see if they're intersecting. If they're intersecting, we should be able to set them equal to each other and solve the equations. So if we solve these equations, what we'll do is the x component is 1 plus 2t is equal to -2 plus 3s, and the y component would be 2 minus t equals 3 minus s. Okay, so let's see. T equals 2 minus 3 plus s. S minus 1. So t equals s minus 1. So 1 plus 2 times s minus 1 equals 3s minus 2. 1 plus 2s minus 2, which would be -1 plus 2s equals 3s minus 2. So that would be s here, 1 here. So s equals 1. And if s equals 1, then t is equal to 0. Now does that work for z? Let's see. Z would be 3 plus t equals 1 plus 2s. And then we're going to substitute in t equals 0 and s equals 1 and see if those equal to each other. 3 equals 1 plus 2 equals 3. Good. So that means that when s equals 1 and t equals 0, both of these lines have the exact same point. And if they do, that means that they are, okay, so this pair of lines is intersecting. They're intersecting. Okay, so intersecting. And then now that we know that they're intersecting, let's find out the acute angle between them. Okay, so we're going to take the two direction vectors, 2, -1, 1, and we're going to scalar product them together, and we're going to get 6 plus 1 plus 2, which is 9. Okay, so that's the scalar product. The magnitude of each of these, the magnitude of that is 4 plus 1 plus 1, square root of 6. The magnitude of that is 9 plus 1 plus 4, square root of 14. So the cosine of the angle between them is equal to 9 divided by the square root of 6 times 14. Okay, and we could do that on our calculator here. We're going to find 9 divided by root 6 times 14, which is equal to 0.91982. And what's the inverse cosine of that? That would be our theta. It's 0.19. And let me just make sure I'm in degree mode here. And I'm not. I think it's easier in degrees. It means more to us. So let's try this again. Inverse cosine of 0.982. 10.9 degrees. So theta equals 10.9 degrees. That's the other thing they wanted us to find, the angle between them. Okay? Now see. We're going to do the same thing. We're going to see if parallel, intersecting, etc. So for this one here, the position vector would be 0, 3, -1. 0, 3, -1. And then the direction vector would be 6, 8, and 2. And what about this one? This would be 2, 0, 1. And this one would be 3, 4, 1. Okay, and do you see how these two direction vectors are multiples of each other? So that means that they are either parallel or coincident. Okay, so either parallel or coincident. Now let's see if they're the same vector. If they're the same vector, then or the same line, then we can actually find the same point between the two. Or we could like see if is it possible, is like this point on this line? So let's try that. We're going to say, hey, is this point 0, -3, 1 on the line 0, 2, 0, 1 plus s 3, 4, 1? We'll see if that's true. So basically that would be 0 equals 2 plus 3s, and 3 equals, 3 equals 4s, and -1 equals 1 plus s. So that says that s equals -2, and if we put s equals -2 in there, it doesn't work. 3 equals 4 times -2, that doesn't work. So there is no solution. So that means that this point 0, 3, 1 is not on this line, which means they are not coincident. They must be parallel because they have the same direction, but they're not coincident, so they're parallel. And we don't need to find the acute angle between them because the acute angle between them is 0 degrees. They're parallel. Okay, last one. So we're going to write them out again as parametric equations. So we're going to have 1, 2, 3, 1, 2, 3. And we're going to add the direction, which is 1, negative 1, 2 for that one. And for this one, it's 2, 3, negative 5 plus s times, and the direction is 3, negative 2, 1. And if you look at these two direction vectors, they are not parallel. They don't look like they're multiples of each other. So we're either going to be skew or intersecting. So let's see if we intersect. If we intersect, that means that we could set these two equations equal to each other, and then we would be able to find a point which satisfies both. And so we could say the x components are equal to each other. We could say the y components are equal to each other. Oops. 2 minus t equals 3 minus 2s. And the z components are equal to each other. 3 plus 2t equals negative 5 plus s. Okay, and let's take this one here. We'll say t is equal to 1 plus 3s. And then we'll take that and we'll put it into here and see if it works out. 2 minus 1 plus 3s equals 3 minus 2s. 2 minus 1 minus 3s equals 3 minus 2s. S equals, this would be 1 minus 3. 1 minus 3 is negative 2. S equals negative 2. So if s equals negative 2, that means t equals 1 plus 3 times negative 2, which is negative 6. So t equals negative 5. T equals negative 5. Okay, and we're going to take both of those and we'll put it in here. Negative 5 here, negative 2 here. And then we get 3 minus 10, which is negative 7. And then we have negative 5 minus 2, which is negative 7. And it worked. So that means that, yes, there is a point which satisfies both of these equations. It is found at s equals negative 2 and t equals negative 5. Let's figure out exactly. Okay, so if we know that there is a point that satisfies that, it's an intersection. And what do they want? They want to know the measure between these two vectors. So what we're going to do is we're going to find, we're going to multiply, we're going to scalar product these together. 3, negative 2, and 1. And then we get 3, and then we get plus 2, and then we get plus 2, and then we'll have 7. So the scalar product is 7, and to find the angle between the two, we need the scalar product in the numerator. In the denominator, we need the magnitudes. The magnitudes would be square root of 6. If we put that in Pythagorean's theorem, we get square root of 6. And here we get 9 plus 4 plus 1, which is square root of 14. In the denominator, we get 6 times 14 root. So we put that in the calculator. We have 7 divided by root 6 times 14. That gives us 0.764. If we take the inverse cosine of that, we get 40.2 degrees. And then we're done.